Document revision history. This network documentation is a living document that is changed as required to reflect system, operational, or organizational changes. Modifications made to this document are recorded in the version history matrix below. At a minimum, this document will be reviewed and assessed annually. Reviews made as part of the assessment process shall also be recorded below. This document history shall be maintained throughout the life of the document and the associated system. First, on the 7th of October 2024, the Information System Security Officer reviewed the network setup from Part A. Next, on the 8th of October 2024, the Team Leader and Troubleshooting Assessor identified common network issues within the system. On the 10th of October 2024, a test network connectivity was done by the admin, and on the 14th of October, the Team Leader and Troubleshooting Assessor diagnosed the issues within the host in the system. On the 16th of October, the admin resolved those host-to-host connectivity issues, and on the 21st of October, the Information System Officer resolved Internet server connectivity issues. Next, on the 22 October, the Team Leader and Troubleshooting Assessor documented diagnostic and resolution, admin prepared preliminary documentation, and complete final documentation, and finally, the Team Leader and Troubleshooting Assessor review and make the final edit. Here are the team members of this group. The position of Team Leader and Troubleshooting Assessor is held by Muhammad Jafri Dini bin Jafni. Next, System Administrator is held by Alif Hakimi bin Aziz as well as Muhammad Aiman bin Shazali. And finally, Information System Officer Security is held by me, Muhammad Firdaus HAYAT bin Muhammad Faisal. Next, I will be explaining the host and network devices information in the system. First off, we are using 7 PCs and 1 internet server in the server. The operating system of the PC are using Windows. Meanwhile, the internet server is using Windows Server 2016. The first device is the hub. The model number for this hub is the ISR 4300 and the description is Central Edge Router. The interfaces that is used is the G000 connected to the ISP, S010 connected to branch 1, S011 connected to branch 2, and finally S020 connected to HQ. The routing protocol used by the serial port is OSPF, while for G000 is static routing. The next device is the HQ, model number ISR 4300, and the description is connected to hub. The the interfaces that is used is the G00.1 connected to the SVHQ1 and the S010 connected to hub. The routing protocol for the S010 is OSPF and G000.1 is inter-VLAN. Next device is the factory, model number ISR 4300, and the description is connected to hub. The interfaces used is G000 connected to SWF1, G001 connected to SWF2, and S010 connected to hub. Both gigabit interface is default routing, meanwhile the S010 is OSPF. Branch 1's model number is ISR 4300 and it is connected to the hub. The G00 interface is connected to SWB1 using the default routing, and S010 connected to the hub using the OSPF. Branch 2 is mostly the same, but the interface is G000.1 connected to HWB2 using the inter-VLAN routing, and H010 connected to the hub using OSPF. The final device is the ISP, and the description is simply the ISP router. Interfaces used is G000 connected to the hub with static routing, and G001 connected to the internet server with default routing. Now I will be going further in depth into the devices used in our system. For the HQ switch, the device name is SWHQ1, model number WSC296024TT, and the description is HQ switch 1. The IP address is 162.168.6.252, and the domain is mode server. As you can see, the interfaces are mostly inactive, bearing FA01, which is connected to the user, FA019, which is port channel 1 trunk to HWHQ2, the same as FA020, and FA23 port channel 3 trunk to HWHQ3. G01 is used to trunking to the HQ router, and VLAN 1 is used in FA01 with an IP address of 192.168.6.252. Next up is the HQ switch 2, also known as HWHQ2. Like the first HQ switch, the port used are FA01 access port to user, FA019 and FA020, which is port channel 1 trunk to SWHQ1, FA021 and FA022, which is port channel 2 trunk to SWHQ3, and finally VLAN 1 with an IP address of 192.168.6.253. The next device is SWHQ3 or HQ switch 3. The FA01, which is access port to user, FA021 port channel 2 trunk to SWHQ2, FA022 port channel 2 trunk to SWHQ2, FA03 and FA024 port channel 3 trunk to SWHQ1, and finally VLAN 1, which is 192.168.6.254.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman and I'm System Administrator. Okay, so we can go to branch switch. For SWB1, we use a switch for branch 1, and for the port that I use is for example G01 connected to branch 1 router, and I use VLAN 1 that IP address is 192.168.1.252. Okay, for SWB2 I use branch 2 as I use switch for my branch 2. Okay, I use model IP address 162.168.2.70. Okay, that's I use port FA01 access port to user. Okay, and FA012 access port to user 2, and after that I use G01 for trunking to branch 2 router, and for the VLAN is 192.168.2.70. yes, and all other not usable port, I not use the port, and the port is inactive. Okay, for the factory switch, I use switch 1 for the factory SWF1. Okay, for the port is I use G01 to connect to the factory router, and VLAN is 192.168.3.252. Okay, for the IP address for the factory switch 1 is 162.168.3.252. Okay, for others, I use SWF2 as factory switch 2, that IP address is 162.168.4.252. Okay, for the use port is G01 connected to factory router, and the VLAN 1 is 162.168.4.252. Okay, so this is my network topology, and I use hub as the center and had the switch a router like ISP, branch 1, branch 2, factory, and HQ. I use switch to connect to the PC and make as a switch for the other use to my company. Okay, such as PC1, PC2, PC3, PC4, PC5, PC6, and PC7. Okay.
Okay, now I'll walk you through a detailed configuration and implementation overview of our network setup. We'll cover key aspects like device configurations, VLANs, layer 2 security, ACLs, NAT, and routing protocols. Let's begin with the PC configurations. Each PC is assigned an IP address, subnet mask, and default gateway based on their respective network segment. Here's a summary. PC1's IP is 192.168.1.153. Subnet mask is 255.255.255.0. Its default gateway is 192.168.1.1. For PC2, the IP address is 3.50. Subnet mask is the same. Default gateway is 3.1. For PC3, its IP address is 4.115. Subnet mask is the same. Default gateway is 192.168.4.1. For PC4, the IP address is 5.83. The subnet mask is 255.255.255.128. The default gateway is 5.1. For PC5, the IP address is 5.227. The subnet mask is 128. The default gateway is 192.168.5.129. For PC6, the IP address is 2.48. The subnet mask is 224, and the default gateway is 2.33. Lastly, for PC7, the IP address is 2.67. The subnet mask is 224, and the default gateway is 2.65. Let's begin. Similarly, router interfaces are segmented as follows. For branch 1 router, for interface G000 with IP address 192.168.1.1.
Mana kau download packet tracer dia?
With default gateway of 24. For interface S010 with IP address of 192.168.0.2, and the subnet mask is 30. For factory router, the interface G000 with an IP address of 3.1 and subnet mask 24, and the interface G001 with IP address of 192.168.4.1, and the subnet mask is 24. For HQ router, sub-interfaces, interface like G000.1 for VLAN with an IP address 6.0 and subnet mask 24. And lastly, the branch 2 router, multiple sub-interfaces for VLANs, G000.1 for 192.168.2.1, subnet mask 27. And next thing is VLAN setup, switch port and trunking. VLANs are deployed to segment networks effectively. For an example, switch 5 is assigned VLAN 1 with an IP address of 192.168.6.252 and subnet mask 24. Switch ports are configured for access and trunking. Access port connect PCs to their VLANs. For an example, interface F01 on switch 0 is an access port, and trunk ports connect switches and routers to allow VLAN traffic. For an example, the interface G01 on switch 5 serves as a trunk port. For L2 security implementation, to enhance security, we've configured port security and implemented the spanning tree protocol, or SDP. Port security restricts unauthorized devices on switch ports. For an example, interface F01 allows a maximum of 2 MAC addresses with sticky learning, and SDP prevents network loops. For an example, VLAN 1 is configured with a primary root bridge for stability. Next is access control list, or ACL implementation. ACLs are critical for managing traffic and securing network. For an example, we may this command: access list 100 permit IP 192.168.6.0 and the subnet mask 0.0.0.255 any, and access list 100 deny IP any. This is applied to the G00 interfaces as an outbound rule to regulate internet access. Next one is NAT implementation. We've deployed network address translation, or NAT, for external communication. For an example, NAT overload is configured to allow private IPs to access external networks. Based on this command right here, IPNet NAT inside source list 1 interface G001 overload. NAT interfaces are designated as inside or outside based on their roles. Next is routing protocol, or OSPF. Finally, OSPF is the chosen routing protocol for dynamic communication between branches, HQ and ISP. OSPF provides efficient routing through area-based segmentation. For an example, the command that we did, router OSPF 11 and network 192.168.0.0 and subnet mask of 0.0.255.1255 area 0. All of this ensures seamless inter-network communication. Lastly is the conclusion. In conclusion, our network design integrates segmentation, security, and dynamic routing to ensure optimal performance and robust security. With VLANs, ACLs, NAT, and OSPF, we've built a reliable and scalable network architecture. Thank you, and thank you for listening. That's all.